Hello dear students, today we are going to make a general revision about our course of science. I wish you will enjoy this revision. First, we will going to talk about physical and chemical properties for any matter. We will remember what are the physical properties. We have 7 physical properties. Number 1, taste, color and smell, and how can we distinguish between materials from tasting, like when we distinguish between salt and sugar, by smell as we distinguish between vinegar and perfume, by color when we distinguish between iron, gold and copper. This is the first physical property. Number 2, the density, and the density is the mass of unit volume, and we talk about density that D equal M over V. The density is the same for the same matter. As the mass change, the volume also will change and the density will stay constant for the same matter. And also density measuring unit is gram per cubic centimeter. The density, we have water density equals 1 gram per cubic centimeter, and some materials float above water surface if their density is less than the density of water or less than 1, and some of them sink in water if their density is more than 1 or more than the density of water. So when we have give reason, a piece of cork float above water surface but a copper coin sink, we will say because cork's density is less than the density of water, but copper density is more than the density of water. And we also fill the balloons of celebration by helium or hydrogen because their density is less than the density of air, so they float above the air. The third property is the melting point, and we said melting process is a changing matter from solid state to liquid state. But melting point is the temperature at which the matter changes from solid state to liquid state. And we have a very important life application about the melting point. It's about the alloys. We have 3 very important alloys. The first one, copper gold alloy to make jewels. The second alloy is nickel chrome alloy to make heating coils. And the third alloy is stainless steel alloys to make cooking pots. The fourth property is about the boiling point. And we said boiling is the process at which the matter changes from liquid state to gaseous state. And the boiling point is the temperature at which the matter changes from liquid state to gaseous state. And we can separate the components of petrol by using the different boiling points of these components. The fifth property is the hardness. We have some substances are hard at room temperature and can be softened by heating, and some can't be softened by heating. The substances that are hard at room temperature and can be softened by heating, like all metals, of course, except mercury because it is liquid. And the substances which are hard at room temperature and can't be softened by temperature or by heating, by increasing temperature, like wood, coal. And we have some substances which are soft at room temperature, like rubber, which is soft at room temperature. The sixth physical property is about electric conductivity. The electric conductivity, we have 2 groups of substances. Some of them is good conductor of electricity or electrical conductor, and some of them are bad conductor of electricity or electrical insulator. The electrical conductor, like all metals, and some solution like salty solution, acidic solution, and alkaline solution. And the materials that are bad conductors of electricity, like wood, plastic, glass, and some solution like sugary solution and hydrogen chloride solution in benzene. We make the wires from copper and cover it with plastic layer because copper is good conductor of electricity while plastic is bad conductor of electricity. The last physical property is about heat conductivity, and also the substances are divided into good conductors of heat and bad conductors of heat. And the good conductors of heat like all metals, and bad conductors of heat like wood, plastic, and glass. We make the cooking pots from aluminum with with wood or plastic handles because aluminum is good conductor of heat while plastic or wood are bad conductors of heat. Now we finished the physical properties. We are going to talk about the chemical properties. In the chemical properties, we talk about only metals, and the metals are classified into 3 groups. The first group is the very active metals like sodium and potassium, and they are kept under kerosene layer to prevent the reaction with oxygen. The second group is less active metals, and these less active metals like iron, copper, and aluminum, and these are the substances that react with oxygen but after a period of time and in the presence of humidity or water vapor. So we paint all the time the lamp holders in the street from time to time to prevent the rust and corrosion. The last group is the inactive metals. They are like gold, platinum, nickel, chrome, or chromine. These don't react at all with oxygen. So they make jewel from gold and silver because they are inactive metals that don't react with oxygen. This is the first point, and this is the first lesson. Today also we will going to revise about the molecule. What is a molecule? Molecule is the smallest part of matter, can exist freely and have the same properties of matter. We have some properties of molecules. We have 3 properties of molecules. The molecules are in a continuous motion. The molecules have intermolecular spaces, and the intermolecular spaces are the spaces among the molecules, and the molecules have intermolecular forces, and the intermolecular forces are the forces among the molecules. The molecules of solids are different from liquids and different from gases in their properties. In the motion of solids, they are vibrational motion, and in liquids, intermediate motion, and in gases, it's a freely movable. The intermolecular spaces among solids are very narrow, and in liquids are intermediate, and in gases are very large. The intermolecular forces among the molecules of solids are very strong, and in liquids intermediate, and in gases these forces are very weak. The third part is about element and compound. Element is the simplest pure form of matter, can't be analyzed into simplest form. And the element molecules may be found in a form of monoatomic molecule or diatomic molecules. The monoatomic molecules, they are the molecules that made of only one atom. And we have liquid, the only liquid monoatomic molecule element is mercury, and the gases are the inactive gases or the noble gases or the inert gases, and they are 6 gases: helium, neon, xenon, radon, krypton, and neon. So again, helium, neon, argon, krypton, xenon, radon. These are the noble gases or inactive gases. The diatomic molecule elements, this molecule is made of 2 atoms, and these 2 atoms must be similar or of the same kind. Like only one liquid, it's bromine, and we have some gases like oxygen, hydrogen, nitrogen, chlorine, fluorine. These gases are active gases and diatomic molecular elements. What about the compounds? Compounds are substances that their molecule is made of 2 or more atoms for different elements. So the compound made of more than one element. Like the examples in our course, hydrogen chloride, HCl, is made of 1 hydrogen atom and 1 chlorine atom. Water molecule, H2O, made of 2 hydrogen atoms and 1 oxygen atom. And ammonia gas, which is made of 3 hydrogen atom and 1 nitrogen atom, so its symbol is NH3. We are today also going to talk about the atomic structure. Each molecule is made of a smaller unit, which is called atom. And the atom is the smallest part of matter which share in chemical reaction. Any atom made of 2 parts. The first part, its name is nucleus. And the nucleus, as we see here, made of 2 or consists of 2 types of particles. The first type of particles, its name is protons, and they are positive charged particles. And the second type of particles inside the nucleus, its name is neutrons. So this is nucleus. So the atom consists of nucleus, which consists of positive protons and neutral neutrons. And there are negative charged particles which are called electrons. And these electrons are revolve in levels which are called energy levels. And we have 7 energy levels in the biggest known atom till now. Some of them, of course, have 1 or 2 or 3 or 4 or any number, but the biggest or the largest atom have only 7 energy levels only, okay? The name of energy level starts from K and ends with Q, K, L, M, N, O, P, Q. What are these energy levels? These are imaginary orbits in which the electrons revolve around the nucleus. And as I told you, they are characterized by the symbols K, L, M, N, O, P, Q. And these energy levels, their name is energy level because each level has a certain energy. And this energy increases when we go away from the nucleus. So K energy level has the least energy, and the Q energy level has the biggest energy. Each energy level carry a certain number of electrons according to the relation 2n powered by 2, and n is the number of energy level. So the first energy level carry only 2 electrons, and the second energy level carry 8 electrons, and the third carry 18, and the fourth carry 32. And we can't obtain this rule or this relation for the energy levels for more than the fourth one, because the atom becomes unstable. So the number of electrons in each energy level is obtained from the relation 2n powered by 2. We also must remember how the electronic configuration occurs when I give you any symbol. This symbol will have two numbers, one of them down and downward and the other is upward. The big or the upward number is known as the mass number. What is the mass number? The number of positive protons plus the number of neutral neutrons. And the downward number, or this less number, is known as atomic number. And the atomic number is the number of positive protons only. And as we knew before, the positive protons must be equal to the negative electrons, because the atom must be electrically neutral. Electrically neutral means has no electrical charge. Why? Because the number of positive protons should be equal to the number of negative electrons. When we make electronic configuration, we distribute the number of electrons in the energy levels. So we will write K carry 2, L carry 8, and the last one M carry only 1 electron. And this, its name is electronic configuration. Don't forget, we distribute the atomic number, not the mass number, because we must know the number of electrons in the energy level, not the protons and the neutrons. Let's return back here. So this point is finished, the atomic structure and the energy levels and the electronic configuration. Now we will start in Unit 2. In Unit 2, we talked about energy. What is the energy? Energy is the ability to do work or to make a change. And we have many types of energy, like sound energy, heat energy, mechanical energy, potential energy, kinetic energy, light energy, solar energy, many energies. And also we talked about the resources of energy, and we said that the main resource of energy is the sun, and also the sun is the permanent resource of energy. And also, as we knew before, that we have renewable resources of energy which renew itself, like wind, waterfall, and sun is permanent, as we said. And we have non-renewable resources of energy like petrol, coal, and natural gas. And in the first lesson, we talked about potential energy, kinetic energy, and mechanical energy. We must know what are the factors that affect each one, and what is the rule, and what are the problems can come in this part. Potential energy is the energy stored in the object due to its new position, like when I hold this pen like this. So the potential energy is affected by two factors, weight and height. So the factors affect the potential energy, weight and height. While the factors affect kinetic energy, because kinetic energy is the energy during the object motion. So the energy of the object motion, it's responsible for the motion. It's affected by two things, the mass of object and its speed or its velocity. So the kinetic energy affected by mass and velocity. If we want to know the rule of potential energy, its rule is weight times height. So the potential energy equals weight times height. And we must remember, how can we calculate weight? We calculate weight from mass and gravity, because weight, which is W, equals mass times gravity, M times G. And the height given. The kinetic energy is equals to half mass times V bored by 2. So it's equal half times m times v square or powered by 2. When we talk about the mechanical energy is the summation of potential energy plus kinetic energy. Of course, in problems, maybe I will bring to you potential energy equals a value and kinetic energy equals a value, and I will ask you what is the mechanical energy. You must write the rule. Mechanical energy equals potential energy plus kinetic energy, and then you will put these two values and calculate the mechanical energy. Of course, all the energies measuring unit is joule. And this is the simplest form of problems. And maybe I will bring it, need more steps and be attention about this type of problems. I will bring to you mass and weight and height and velocity and ask you to calculate the mechanical energy. Then you must calculate first the potential energy, which is equal to weight times height, and bring its value. Then you must calculate kinetic energy, which is equal half mass times v bored by 2, and also you will find its value. Then you will write mechanical energy equals potential energy plus kinetic energy, and you will bring these two values which we calculated before, and you will bring the mechanical energy finally. This type of problems is very important. Then we talked about energy transformation. The energy can't be created nor destroyed, but it can be transformed from a form to another. And this, its name is conservation law of energy, or the law of conservation of energy. And we have many transformations of energy, like the solar cell converts solar energy to heat energy, to electric energy. The solar heater converts the solar energy to heat energy. The lamp, it changes the electric energy to light energy. But if he asks you about the filament of the lamp converts electric energy to heat energy, because the filament must be warmed up before lighting the lamp. The sewing machine, it changes the electric energy to kinetic energy, and also does the fan. The nuclear reactors, it changes the nuclear energy to electric energy. And we have many transformation of energy. Of course, don't forget the simple electric circuit and the simple electric cell. The simple electric circuit is the electric circuit that consists of battery, lamp, switch, and wires. And we said some deaf people and some blind people. The blind, of course, we will replace the lamp with electric bulb. And the deaf, of course, we will replace the electric bulb with electric lamp. And also, we said this type of electric circuit, it changes electric energy to light or to sound, as the instrument we put. If we put a lamp, so it will change electric to light. If we put electric bulb, so it will change the electric to sound. And also we talked about the simple electric cell, and let's remember its shape. It consists of 3 parts. The first part is the 2 poles. The first pole is made of copper and the second pole is made of zinc. And we put them in acidic solution, and this acidic solution, its name is sulfuric acid, and its sample is H2SO4. And when we draw it like this, and this is a lamp, the electricity will move from the positive pole, which is copper, to go to the negative pole, which is zinc. And also this simple electric cell, it changes the chemical energy into electric energy. And also we must read carefully how the transformation of energy inside the car engine occurs. The third lesson in this unit is about the heat energy. What is the heat? Heat is a form of energy that is transformed from higher temperature object, which is hot, to lower temperature object, which is cold. So heat transferred from higher temperature or hot object to cold object. And we must know what is the temperature. Temperature is an indicator, and this indicator helps us to know the direction of transferring heat from the object or to the object. So when I know that its temperature is, for example, 100, so the heat will transfer from it to the surround or to the touched object. When I told you this cup of juice, its temperature is 5, and when I hold it, so the heat will transfer from my hand to the cup, because it transfers from the higher temperature to lower temperature. What are the ways of transferring heat through different media? The first way, its name is conduction, and the conduction occurs in solids. And also we must remember that we have some good conductors of heat and some bad conductors of heat. So the first way, its name is conduction, and the conduction in solids. The second way, its name is convection, and the convection occurs in gases and liquids. And the convection occurs when the hot and the cold currents replace each other. What is the meaning of this? The cold current, although it is liquid or gas, has big density, so it goes down. And the hot currents has a low density, so they go up, and the cold replace it. So we can see that the heat is transferred through solids and liquids by convection, because most of them are bad conductors of heat, so we can't transfer it by conductions. The third way, its name is radiation. If I have a very hot object like the sun or the heater, and it radiates heat. Radiate means emit heat without needing any materialistic media, maybe from the space to us, like it happens in the sun, and maybe occurs in also materialistic media like the heater, when it radiates heat to us and we feel it's warm. So when I have a question how the heat of the sun reaches to the earth, we will say by radiation. Only radiation, because there is a big space between us, and because the atmospheric air is bad conductor of heat. But when he asked me how the heat of the heater, the electric heater, is transferred, I must say two ways. Convection, as the hot air goes up and the cold air goes down, touching the heater and become hot and goes up, and etc. And also by radiation, because of this we feel the warmth of the heater anywhere in the room. So the heat of the heater is reached to us by two ways: convection and radiation. Of course, don't forget the diagram of the sun. The sun has solar energy, and this solar energy, it changes to electric energy by electric cell. It changes to chemical energy by the photosynthesis process, which the plant doing it to make its own food, and also a change to chemical energy as the sun helps to form the fuel, petrol, coal, and natural gas, and also it changes to heat energy like an and solar heater and solar oven and solar stove. Don't forget this diagram, it's a very important. The last unit, it's about the living organism. And we said that this lesson is divided into two main parts. The first part, its name is diversity, and the most important part in this part, how can we diverse animals and plants and microorganisms or unicellular living organisms. The plant, we diverse it by two things, huge and small, from the size and the size of the leaf. We have small leaves and large leaves, like a banana tree which has large leaf, and ملوخية and gargir, which clover, have small leaves. The size like a clover, which is a small plant, and grass, and also we have camphor and palm trees, which are very huge. We diverse animals according to two things. Number one, the size also. We have very huge animals and small animals. The huge animals like rhinoceros, giraffe, elephant, and the small animals like rat and jerboa and squirrel, they are very small. Also the environment where they live. Some of them live in water and some of them live on land. Which live on land like any animal I know, elephant, donkey, monkey, cow, and which live in water like fish, dolphin, whale, and these types of living organisms. Number two, we will talk about the classification, and we must pay attention about the classification of plants and animals. Oh, I'm sorry, I forgot to talk to you about the unicellular living organism or the microorganism. The microorganism or living organism can't be seen by naked eyes, but we need microscope to see them. So they are unicellular, all their body is made of one cell or only one cell, like amoeba, euglena, paramecium, and they are different from each other by two things, the external shape and the way of movement. So we can differentiate between them from the external shape or way of movement. When we talk about the classification of plants, it's very important to know that the plants are classified according to two things. Number one, external shape. Some plants can be distinguished into root, stem, and leaves, and some can't be distinguished into root, stem, and leaves. The plants which can distinguish like weed, like corn, like trees, and which can't be distinguished like algae. And algae have many colors, red, green, and brown. The second type of classification of plants according to the way of reproduction. Some plants reproduce by forming spores, and these plants like Vogere and Adiantum. And some reproduce by forming seeds, and these plants which reproduce by forming seeds are classified into two groups. Some of them, its name is gymnosperm, and some are called angiosperm. The gymnosperm are the plants without a precarp or without covers, like pine and cycas, and the angiosperm with precarp or with covers, like and these divided into two groups also, monocotyledon and dicotyledon. Monocotyledon like corn and wheat, and dicotyledon like bean and peanut and pea. When we're going to classify animals, the first classification according to the presence of teeth. Some of them have teeth and some without. The animals without teeth, like sloth and armadillo, these two animals without teeth. And the animals with teeth, like, of course, divided according to the type of food they will eat. Some of them have front teeth extended outward like hedgehog, and some has molar and canine, which are sharpened and pointed like any carnivore, lion, tiger, cat, all of these. Some have front sharp incisors, and the sharp incisors, these front teeth are called incisors, and these are divided into two groups, rodents and logomorphs. Rodents like rat have only one pair of teeth in each jaw, and lagomorphs like rabbit has two pairs in the upper jaw and one pair in the lower jaw. And also we classified animals in a special group. Its name is arthropods. What are the arthropods? Arthropods are animals or a type of living organism which is invertebrate without a vertebral column, but their body is connected with jointed legs. And these arthropods are classified into three groups: insects, arachnids, and myropods. Insects which have three pairs of jointed legs, means 6 legs, like ant, cockroach, fly, butterfly, mosquito, bug, locust. All these are insects. Why? Because they have 6 pairs of jointed legs, 3 pairs of jointed legs or 6 legs. And also we have arachnids. What are the arachnids? Arachnids characterized by having 4 pairs of jointed legs or 8 jointed legs, like a spider and a scorpion. So spider is not insect because it has 4 pairs of jointed legs, or its body connected with 4 pairs of jointed legs. So it belongs to arachnids. And the last group, its name is myropods, and myropods has numerous number of legs like Julius. And then we finish this part and we must talk about the definition of a species. What is the species? A species is the main classification unit of living organisms. So a species is the main classification unit of the living organism. The last part is the last lesson is very long, but we want only a very small part of it. The types of adaptation. Adaptation means a modification in a structure or behavior or function of an organ of living organism. So the types of adaptation: functional, behavioral, and structural adaptation. Functional means I have the same organ, doesn't it change, but its function, it changes to adapt to the environment, like the salivary glands, which secretes only saliva. The sweat glands, which secrete only sweat during summer and stop secreting in winter, like the salivary glands in poison, which secrete poison instead of saliva. Number 2, the structural adaptation, like the foot of a horse, which is called hoof, and the foot of camel, which is called pad. And the last type of adaptation, its name is behavioral adaptation, like birds' migration and the activity of bat during night, while all birds' activity during morning. The last part I want to make you pay attention about it. If I throw a ball upward, what will happen? When the ball is thrown upward, so it moves against the gravity. Gravity wants to pull it down, so it moves upward. So its velocity will decrease. And then the kinetic energy will decrease, and height will increase, and potential energy also will increase. And if I throw the object downward, I left it to move to the down. This means that it moves with the gravity, and this means that its height will decrease. When the height decreases, the potential energy decreases, and the velocity increase because it moves with the gravity, and this tends to the increase of kinetic energy. This is the most important rules in your course. D, density equals mass over volume, and don't forget it's by gram per cubic centimeter, the measuring unit. The rule of distributing the first four electrons in the first four energy levels is 2 n powered by 2, and potential energy equals weight times height, and of course potential energy is measuring unit is joule, and weight equal mass times gravity, and the measuring unit of weight is Newton. Kinetic energy equals half mass times V powered by 2, also by joule. Mechanical energy, potential energy plus kinetic energy by joule. And the last thing is work equal force times displacement, and displacement, we can say it's a distance or displacement by meter, and force by Newton, and of course work by joule, like any energy. Stay safe, study hard, and God bless you all. Thank you. في حتة